Scientists discover mysterious quantum pressure from a black hole. When black holes were first discovered, it was thought they were completely inert. The death of a star was supposed to be the end of it. In 1974, Stephen Hawking proved otherwise with the discovery of black hole radiation. Now, almost 47 years later, it seems like humanity had made a similar breakthrough. Curious? Well, let's get right into it. In a recent research conducted by astronomers Javier Calmet and Volker Kuipers from the Department of Physics and Astronomy at the University of Sussex, found that black holes emit quantum pressure. Before we dive deeper into what this discovery means and why scientists are freaking out over it, we need to take a look at the events that led to this discovery, and for that, we need to go back, way back. In 1916, many big things happened, two of which were the publishing of Einstein's theory of relativity and the first time someone brought up black holes. Einstein was the one that did both of these things. For much of human history after these events, black holes were thought to be just what the name says, black balls, well, spheres to be exact, of matter so dense that they had a gravitational pull strong enough to pull anything inside. It was declared that even light was not fast enough to escape the gravitational pull of a black hole, and hence they were called just that, black holes. Quite a fitting name if you think about it. American astronomer John Wheeler was the one to come up with it in 1967, 51 years after black holes were first theorized. Stephen Hawking's discovery. Stephen Hawking proved that black holes are in fact not inert and emit radiation. This further proved two more activities that black holes perform, one being it having a temperature and the second, it shrinking over time if it had no acceleration. Before this, it was considered that black holes didn't emit anything since everything was sucked up inside. Hawking, however, proved that radiation consisting of packets of energy, called quanta, was capable of not being affected so much by gravity and was able to escape the pull of a black hole. This was a huge deal at the time and led to many more advancements in the field of astrophysics. One of the biggest being that black holes, which were previously thought to be inert, useless objects, started to be considered complex thermodynamic systems that emitted specific black body radiation, making them the ideal laboratory to investigate the interplay between quantum mechanics, gravity, and thermodynamics. The discovery. Now, we have another discovery just like this. While researching quantum gravity coming from a Schwarzschild black hole, a Schwarzschild black hole or static black hole is the simplest type of black hole and doesn't process any angular momentum. These are the black holes that scientists prefer to perform research on since they're relatively simpler to study and offer one less factor to worry about in an already super complex environment. Astronomers Javier Calmet and Volker Kuipers, the brains of the entire operation, were surprised by an extra figure that kept showing up again and again as they studied changes in gravitational forces caused by the behavior of quantum particles at the edge of black holes. After an in-depth analysis of the figure from repeated tests, they concluded that the figure must represent the pressure being exerted by the quantum gravity. This discovery was a huge shock for the entire astrophysics community since it was completely unthought of that this was even possible. It opened an entirely new field of study and added another layer of information to the study of black holes. Scientists aren't really sure how this pressure is generated, but they are working on it. Future of black holes. First of all, it opens the floodgates for a lot of questions. The first of those being the obvious: how does a black hole, an object so densely packed at one point in space that even light cannot escape its gravitational pull, manage to exert pressure in the first place? Secondly, how is this related to the thermodynamic properties of black holes? For example, what relationship does this pressure have with the volume of the black hole? The temperature. Are the standard laws of temperature and pressure applicable to it? Or is the current hypothesis that laws of physics deteriorate inside the center of black holes true? These are all questions that scientists are rushing to find out. They're curious too, but realistically speaking, most of those questions are going to take years, if not decades, to answer. This discovery is going to widen our understanding of the observable universe and push humanity towards a future full of new discoveries. The scientific community is hailing this as a new milestone in the advancement of human progress. Professor Falkert announced that, "I'm delighted that the research that we are undertaking at the University of Sussex into quantum gravity has furthered the scientific community's wider understanding of the nature of black holes." To conclude all that we've said so far, scientists have just discovered a new property regarding black holes, and it's the biggest discovery in the field after Stephen Hawking's breakthrough almost half a century ago. This new property of black hole to exert pressure on the environment came after researchers were studying the motion of particles near a black hole due to quantum gravity. The future holds promise and many new exciting discoveries, but those will take years, if not decades. That was all about today's video. Thank you so much for watching. If you liked the video, don't forget to give it a thumbs up and leave your thoughts in the comment box down below. We will see you in our next video. Till then, take care.